So this example is in 2 dimensions, but it's absolutely identical in 3 dimensions. So we have an equation of motion here, and you should be able to look at this and instantly tell me 2 things about it. First one is that the starting point is 20, 30, and the velocity is 6, 8, 6 across, 8 up, and that means that the speed is the square root of 6 squared plus 8 squared. However, when once you've got past that, we should write this type of equation of motion like this, because you should think of this as a coordinate. And in fact, it's quite nice to simply write it as a coordinate. And because you're so much better at thinking about coordinates than you are vectors, everybody is, we totally understand this. This is a coordinate. It's just moving. It just means that as t changes, this point just moves somewhere. So this question is basically saying what is the shortest distance between this stationary point B and this moving point R? So what we do, the method is we find the distance between these 2 points, and then we find the minimum of it. So to find the distance between 2 points, we have a formula on the formula book. And it's given here, but you know it, I'm sure. The distance between 2 points, you just subtract the coordinates, square them and add them. It's Pythagoras. Notice it's in 3D, ours is in 2D. So I'll do that. And then I don't attempt to simplify this at all. Notice I did it, this one, subtract that one. It doesn't matter which order you do it, but I did it that way around just to cut down on the minus signs and the potential for error. So as I said, I don't simplify that. I could, obviously, but I don't. Because when I type it into the calculator, I just want to reduce the possibility of error. So there's no need to simplify. I'm just going to write it just exactly as I see it. So I've typed it in, and then I just plot it. And as usual, nothing comes up. So you should know what to do. We're going to press View Window and sort the x-axis out first. You just simply have to use common sense here. Every single time you do the view window, you just say, what's sensible for the x values? Here, x value is time. Clearly, I can't be negative. What is a sensible time? There's not much indication in the question. So I'm just going to put just some basically random number. Not worrying about the y-axis. I'm just going to draw that, and then immediately go zoom auto and get a really nice graph. Remember what you press next. You go back to view window and make the y-axis go to 0. Because we want to see a really nice diagram, because we have to sketch this on the exam paper. There we go. That is a graph of time against how far apart these 2 points are. The fixed buoy and the moving ship. So clearly that we just go G-solve minimum. And then we make a sketch of this on our exam paper. And then we write the answer down. And the question might be, how close was it? Well, it was 22 miles apart. Or when did this happen after 10.4 hours? Really nice.